today's class we will move on to the last topic of first module. So that is on half-range series. So we have seen how to find the Fourier series for a given function. And when you find the Fourier series for the function f of x, in general, it's a series which involves sine and cosine functions. Now in half-range series corresponding to a given function, we obtain either a cosine series or either a sine series. So that is why we call it as half-range series. So it involves either sine functions or either cosine functions. Now half-range series comes when you have a non-periodic function. So suppose you have a function f of x which is defined on some interval 0 to L. ഇനി നമ്മൾ ഹാഫ് റേഞ്ച് സീരീസിൽ ചെയ്യുന്നതാണ്. Now Fourier series is evaluated for periodic functions. So we have in general a function f of x which is periodic of period 2L. So that's how we have seen the Fourier series. നമ്മൾ 2L ലെങ്ത്തിലുള്ള interval അല്ലെങ്കിൽ 2π ലെങ്ത്തിലുള്ള intervalന് periodic ആയിട്ടുള്ള ഫംഗ്ഷനാണ് നമ്മൾ Fourier series ആയിട്ട് റെപ്രസെൻറ്റ് ചെയ്യുക. നിങ്ങൾ കണ്ടീഷനും Fourier series converge ചെയ്യണമെങ്കിൽ so the function must be periodic in that case. Now let us see how to find the Fourier series for non-periodic functions. So you have a function f of x which is defined on the interval 0 to L and which is non-periodic. So let me consider an example of a function. So it is x when 0 less than x less than pi by 2 and pi minus x when pi by 2 less than x less than pi. So if we look at the graph of the function, so the graph will be of this form. Okay. So 0 to pi by 2, then pi by 2 to pi. So this will be x and this will be pi minus x. So the function is not periodic. Function is defined only on this interval. In the function, what we do here is we will extend the function f of x. Now there is even extension of the function and there is odd extension of the function. Now even extension is obtained by extending the graph symmetrically about the x-axis. Function even y-axis. Function even aanengil function will be symmetric about the x-axis, about the y-axis. Y-axis ന്റെ അപ്പുറത്തും ഇപ്പുറത്തും നമുക്ക് ഒരേപോലെ ആയിരിക്കും മിറർ ഇമേജ് ആയിരിക്കും കിട്ടുക ഫംഗ്ഷൻ ഈവൻ ആകുമ്പോൾ. So when this is even, so let us see if I extend it as an even function, what happens on the left side. So on the left side even ആയിരുന്നെങ്കിൽ provided this function is even, we will get the same curve on the left side also. So about the y-axis on this side of the graph you have the same curve as on the left side. So here the function now becomes symmetric about the y-axis. So this becomes an even function. Now similarly we can continue the extension. അപ്പോൾ ഇത് minus pi to pi ൽ അടുത്ത നമ്മൾ extend ചെയ്യുമ്പോൾ we will be getting in this form. So from pi to 2 pi we will get again the same shape, then 2 pi to 3 pi, so on. Similarly we can extend the function to the left side, so it will satisfy the condition f of x is equal to f of minus x. So this becomes an even extension. Now even നമ്മൾ plot ചെയ്ത് it will be symmetric about the y-axis. Now let us look at the odd extension. Now odd extension is obtained when you trace a curve symmetrically about the origin. So you have this graph. Okay. So that is pi by 2 pi Now the graph is now extended symmetrically with respect to the origin. That means we have taken f of minus x is equal to f of minus x, sorry, f of cp x. So that is how we get an odd function. So f of x will be, so that will be minus f of minus x. So f of x is minus f of minus x. So when you extend in this form, you will get an odd extension. So odd extension will be like this. So that will be extended symmetrically about the origin. So that will be 0, then you have minus pi by 2 and minus pi. And again in the next interval the same function keeps on repeating. ഈ basic curve അതായത് നമ്മൾ ആ curve complete ചെയ്തു minus pi to pi that curve will be repeating again. So this is how extend the function as an odd function. So this is the odd extension. It's the same way you can extend to this side also. Now provided we are finding an even extension, what happens is our new function reduced to an even function in the interval minus L to L, and when you evaluate the Fourier series, you know that for an even function Bn will be always 0. So we will have only the value for a0 and an. a0 ഉം an ഉം വരുമ്പോൾ that will involve only cosine series. Since Bn is 0, so sine terms will go off. So we will be getting a series which involves only the cosine function. So that gives us the half range cosine series. And again when you extend as an odd function, so odd function the Fourier series a0 to an 0 ആയിരിക്കും. So it will not contain any cosine terms. So only Bn will be there. So we will be getting half range sine series. So that is the half range sine and cosine series. So extend the function f of x by reflecting about y-axis. So we will be getting an even function. So that is we will be using the extension f of x equal to f of minus x. Then the extended function will be even. Now for an even function, Bn will be equal to 0. So the Fourier series will contain only cosine terms. And similarly, if you extend the function f of x by reflecting it about the origin, so that f of minus x equal to minus f of x, so it is odd, then function is odd, and in that case a0 and an will be 0. So the Fourier expansion will contain only sine terms. So for a function f of x which is defined on interval 0 n, you have two possible series. So one is a half range sine series and one is a half range cosine series. Now let us look at the series. So half range cosine series will be f of x equal to a0 by 2 plus summation n equal to 1 to infinity an cos n pi x by L. So a0 will be given by 2 by L integral 0 to L f of x dx, and an will be 2 by L integral 0 to L f of x cos n pi x by L dx. And similarly the half range sine series is given by f of x equal to summation n equal to 1 to infinity bn sin n pi x by L, where bn is 2 by L integral 0 to L f of x sin n pi x by L dx. So let us look at an example. So let us expand f of x equal to pi x minus x square in a half range sine series in the interval 0 to pi to first three terms. So the half range sine series is what we need. So half range sine series is So that is given by f of x equal to summation n equal to 1 to infinity bn sin n pi x by pi vary ivide, and so that will be equal to summation n equal to 1 to infinity bn sin n x. So here L is equal to pi and bn will be 2 by pi integral 0 to pi f of x sin nx dx varum. So let us find out bn. So that will be 2 by pi integral 0 to pi pi x minus x square sin nx dx be 2 by pi pi x minus x square. Now integral of sin x is minus cos nx by n minus pi minus 2x into cos integral sin nx varum sin nx by n square varum, and plus minus 2 into cos nx by n cube from 0 to pi. So upon applying the limit, we will be getting 2 by pi into at pi this will be 0, sin n pi 0 ana. So we will be getting minus 2 into minus 1 whole power n by n cube minus at 0, this will be 0, sin 0 will be 0, so we will be getting minus 2 by n cube. So that will be 4 by pi n cube 1 minus 1 whole power. So therefore the half-range series will be, now we need to find the first 3 non-zero terms. So that will be f of x equal to, so we will be getting 4 by pi when n is 1, we will be getting 2 pi 1 cube sin x, when n is 2 it will be 0, n 3 varumbo we will be getting 2 sin 3x by 3 cube, then 4 varumbo 0 avum, then 2 sin 5x by 5 cube plus etc.